lid because it can't get through the water. The water will always stop the gas from flowing past. You're going to have a bubble. So just like hydrogen, electricity does the same thing. Electricity doesn't flow across bubbles. So we use that theory in our cap design by making our grooves filled with bubbles all the time. If you look at the output, what we got going on? If you look at the output of the cell, you'll see a lot of bubbles going on. Those bubbles, once it starts flowing, here we go, those bubbles will actually create a barrier to the voltage. So even though all these tubes are the same length and they all sit inside there and there's water completely filling in it and it pours out, when this is operating, those bubbles fill that space and keep the voltage from jumping across, which keeps this in a series cell integration. That's how our cell works. In a plate design, you have something similar, but you have to seal up the tops of your plates along with the sides and the bottom so that the voltage can't just jump across the surface of the water. Otherwise, your plates are ineffective. The neutrals are not even, it's like they're not even there. You can take them out and have the same production because nothing is attached inside here. And another thing with hydrogen cell construction that's shouldn't have any type of electrical connection that can touch the water. Anything inside the cell that has an electrical connection will eventually fail. Then wire will eventually fail. Corrosion will cause anything thinner than 20 thousandths to fail in a matter of a couple of months. But with these, every tube is separated by a certain amount of space. So there's no physical connection to anything inside the tube they cannot touch. The only electrical connection is on the outside of the device, and the outside of the device is ground. So the electrical connection to the positive is physically separated from all the other parts. Nothing can touch. There's no way for a part to happen inside, which would cause an explosion. Also, there can't be an explosion because there's always water in the circuit. This kit sells for $450. Everything you need to put hydrogen in a car. There's no controller. There's iron harness, tubing, cell, miscellaneous, and instructions. So, the other thing we wanted to say is the voltage required for hydrogen production is roughly 1 to 3 volts. Any more than 3 volts, you start to see
real quick.
Thank you.
No problem, buddy. I appreciate seeing it. We see it.
Are you giving the talk later on?
Yes, we're just doing a video right now.
Yeah, he's on the seminar posted on the right-hand side window.
Great. So anyway, are you going to hold it?
Yeah, I'll go over all this again. If you want to ask questions there, that's fine. So anyway, one last thing to cover is voltage at your plate, your surface. On my cell, I get about 2.5 volts at each surface, but the resistance on the tubes is a little bit different. So one tube will give me, let's say 3 volts, one tube will give me 2.2 volts. So my tube, because each tube is a different size, they have different resistance, so they give me different voltage. The voltage drop is not actually 2.5 at each, but it's represented that way so that you can see me breaking 12 volts down. And giving you 2.5, whatever. The math wrong, that matters. The point is, you want to be less than 3 volts Optimal 1.5, somewhere in there. Mass production is going to happen somewhere around the 1.5 area. If you have 13 and a half volts and you only need 1.5 volts to make hydrogen, that means 12 volts left over. But when your car's running, you're putting out 13 and a half volts and they're all there. So if your cell only has 2 plates, you've got 12 volts. That's it. You've got 12 volts going here, and 13 and a half running. If you've got 13 and a half running, you're wasting 12 volts. That waste is translated into heat, is the amp draw that you use more than what you produce the hydrogen. And it transfers heat into the steel, which weakens the steel and also helps to dislocate more iron oxide, which gives you a lot more mud, a lot faster. Plus, you immediately start to create water vapor first, and then eventually you create steam. And if I was to take out the inner tubes of this and just leave the electrode in the outer tube, I would have just a straight 12-volt cell, which would overheat probably in about 5 minutes. But it would be an excellent water heater. So if anybody needs a water heater, a water heater, just take the inner tubes out, you've got a perfect water heater.